AWS Certified Solutions Architect Professional. Preparation. The exam questions are scenario based. To begin with, we will explore various scenarios to grasp key concepts, and after that review some sample questions and best way to tackle them. You have a very large number of objects on S3 with unpredictable access patterns. What storage class is suitable for them? S3 Intelligent Tiering is the right answer for this. S3 Standard and Glacier are wrong answers here. Let's look at various S3 storage classes. S3 Standard, this is the default storage class. S3 Intelligent Tiering, this is used where access patterns are not known. It automatically moves data to the most cost-effective storage tier by monitoring access patterns. S3 Standard Infrequent Access, this is for long-lived, less frequently accessed data, for example once in 30 days. Here you are charged for a minimum period of 30 days. S3 One Zone Infrequent Access, this is a variation of S3 Standard Infrequent Access. Here the data is stored in one availability zone. It is less expensive than Standard Infrequent Access storage class. S3 Glacier is for archiving data. In case of Glacier Instant Retrieval, minimum storage period is 90 days and data can be retrieved quickly. In case of Glacier Deep Archive, retrieval time is in hours and it is the lowest cost data archiving solution, and it is used for rarely accessed data. Several EC2 instances in a VPC need fast concurrent access to 10 terabytes of common data. What storage should be used for this data? Amazon EFS or Elastic File System is a simple, scalable and highly available file system that can be easily shared across multiple Amazon EC2 instances. Therefore, this is the right storage solution to use here. S3 will not provide relatively fast access. EBS has limitations around attaching it to multiple EC2 instances, and EC2 instance storage is non-persistent local storage on EC2 instances. Therefore, these are wrong answers. Let's look at various storage types. Amazon EFS or Elastic File System is a scalable shared file storage. Multiple EC2 instances can easily access it. Amazon EBS or Elastic Block Storage can be attached to an EC2 instance. It has limitations around attaching it to multiple EC2 instances. It provides persistent durable volumes and you can create snapshots out of it. Amazon S3 is an object storage. It is highly durable, scalable and cost effective. EC2 Instance Store is temporary storage on EC2 instance. It provides high I/O performance and data is lost on instance termination. Amazon FSx is high performance managed file storage for Windows or Linux systems. A company is running a distributed database across several EC2 instances with enough redundancy. Database needs to store some temporary data on storage that can support very high speed read and writes. What storage solution is best suited for this scenario? So for this we can use EC2 Instance Store, which offers excellent performance as it is directly attached to the instance, providing low latency access for read and write operations. Given that the setup has a redundancy to mitigate the risk of data loss due to instance failures, leveraging the EC2 instance storage for temporary data is the best choice here. While both EBS and S3 offer reliable and persistent storage, they cannot match the high-speed reads and writes offered by EC2 Instance Store. Every department in a company has a dedicated subfolder in a S3 bucket. We need to ensure that IAM users can access only their assigned department subfolders. How can we do that? Here we can use S3 access points. So S3 access points can be used to manage and control access to shared data among multiple teams with varying access needs while ensuring security isolation and simplified access management. Therefore, various department users will be able to access only their own designated subfolders. Now, S3 bucket policy is the wrong answer here, as it does not provide the same level of granular control and configuration that S3 access point can provide in this case. You need a high performance file system with Windows native support. So here you can use Amazon FSx for Windows File Server, which is a fully managed file storage service designed specifically to provide native compatibility with Windows-based applications and workloads. It supports the server message block or SMB protocol. Amazon FSx for Lustre is incorrect answer here, as it is POSIX compliant file system, which is optimized for Linux systems. EFS is not correct either, as we need Windows native support. So let's summarize Amazon FSx file systems. Both are high performance systems. So first we have Amazon FSx for Lustre. This is POSIX compliant and suitable for Linux systems. Then we have Amazon FSx for Windows File Server. This provides Windows native support. Replicate objects in S3 bucket from one region to another. For this, we can use cross-region S3 replication. And for this to work, source and target buckets must have versioning enabled. And to narrow down the scope of replication, we can use filters. AWS Glue Job is a serverless ETL service, and it doesn't have any built-in functionality for cross-region replication of S3 buckets. And S3 transfer acceleration is for faster file uploads to S3. Therefore, both AWS Glue Job and S3 transfer acceleration are incorrect answers. Your static website is hosted using an application server on an EC2 instance. How can you bring down the costs? Since this is a static website, you can host it on S3. You do not need an application server or an EC2 instance. On S3, simply create a bucket, upload your HTML, CSS, JavaScript image files, enable static web hosting on the S3 bucket, and ensure your bucket permissions allow public read access to the objects. That's all. You are all set. Using EC2 Spot instance is a wrong answer. While using a Spot instance will reduce costs, however, a Spot instance can be taken away any moment. Therefore, this is not a reliable way of hosting a website. Amazon Lightsail is not cost effective either. You can easily host a static website on S3 at low cost. Make requester pay for accessing objects in your S3 bucket. For example, you have partner companies which are accessing files in your S3 bucket, and these are really large files. By default, you as the bucket owner would be paying for all outgoing costs for objects in your S3 bucket. Here you want to make the requester pay. The solution to this is to activate requester pays option on the S3 bucket. So when this feature is activated, the requester is billed for request costs when accessing objects in the bucket. Now for this to work, requester must also have an AWS account. Using cost allocation tags is a wrong answer. Cost allocation tags are used to organize your resource costs in your cost allocation reports. For example, production versus test resources. Enable consolidated billing is also a wrong answer. Consolidated billing is used when you want one bill for all AWS accounts in your organization. Speed up file uploads to S3. For this, we can use S3 transfer acceleration and multi-part file upload. Now, S3 transfer acceleration leverages Amazon CloudFront's globally distributed edge locations to accelerate the transfer of files to S3 by optimizing the data path to the nearest edge location before routing it to S3 bucket. While multi-part file upload enables breaking down large files into smaller parts and uploading them concurrently, and then merging them into a single object in S3. Using AWS CloudFront or AWS Global Accelerator on its own would be a wrong answer. Both CloudFront and Global Accelerator leverage AWS's global network infrastructure to optimize the delivery of content and routing of traffic. However, they are not designed for faster uploads per se. When you enable versioning on an existing bucket, what is the version assigned to existing objects in the bucket? Existing objects will have their version set to null. So that is the correct answer. And subsequent update to such an object will result in version 1, which will increment with each update. Therefore, version 0 and version 1 are wrong answers. And any new object that is uploaded to this bucket starts with version 1. Applications on your local premises need access to S3 buckets over NFS or Network File System. So, to enable access to S3 buckets over NFS from on-premises, AWS File Gateway, which is a part of the Storage Gateway service, can be used. Both Volume Gateway and Tape Gateway do not facilitate access to S3 buckets via NFS. So they are wrong answers. Let's look at various storage gateway types. File Gateway accesses S3 as NFS or SMB file shares. It acts as a file interface between on-premise applications and AWS. Volume Gateway. Volume Gateway presents cloud-backed iSCSI block storage volumes to on-premise applications and manages data in Amazon S3. So it facilitates low latency access for frequently used data and supports snapshots, which are stored as EBS snapshots, and local caching. So there are two modes in which it operates. In cached mode, primary data resides in Amazon S3, which frequently access data cached locally for quick access. In the stored mode, primary dataset resides on premises for low latency access while asynchronously backing up to Amazon S3. Tape Gateway. It offers a virtual tape library for backup and archival needs. It stores the virtual tapes in Amazon S3. Find personally identifiable information or PIIs in CSV files in S3 bucket. How would you do that? What service would you use? Amazon Macie is the right solution for that. So what are the examples of personally identifiable information? These are things like social security numbers, credit card numbers, and so on. Amazon Macie can locate such information in your S3 files. S3 select is a wrong answer here. S3 select is used to select data from S3 using SQL queries. And AWS config is also a wrong answer because it does not help us identify any PIIs. Instead, it helps us with configuration management of our AWS account. An application on an EC2 instance accesses a database using database credentials. Where can we store the database credentials securely and rotate them as needed? For this, we can use AWS Secrets Manager. Now, AWS Secrets Manager is a service that helps us securely manage, retrieve, and rotate sensitive credentials, API keys, and other secrets used by applications, therefore eliminating the need to hardcode such sensitive information within application or code. Both AWS KMS and EC2 Instance Store are wrong answers. AWS KMS or Key Management Service enables the creation and control of encryption keys, while EC2 Instance Store provides temporary storage for EC2 instances. So any data stored here is neither secure nor permanent. It's lost when EC2 instance terminates. Let's go over some AWS security services. AWS WAF or Web Application Firewall. It provides protection against common web exploits like cross-site scripting, SQL injection, etc. AWS Shield, protection against DDoS attacks. It comes in two flavors, Shield Standard, which is free, and Shield Advanced, which is a paid service. Amazon Guard Duty, threat detection and monitoring for malicious activity. Amazon Inspector, security assessment, vulnerability scanning, for EC2 and other services. KMS, Encryption Key Management. AWS Certificate Manager. Provision Manage SSL certificates. Amazon Macie. Discover sensitive data. Amazon Detective. Analyze and investigate security findings. AWS Security Hub. Aggregate security findings. Cloud HSM is a hardware-based key storage. Amazon Cognito for authentication, authorization, and user management for web and mobile apps. How can you safeguard your web application from common web exploits like SQL injection, cross-site scripting, etc.? For this, you can use AWS WAF or Web Application Firewall, which you can configure with custom rules and filters to control web traffic and mitigate security threats. Both AWS Shield and CloudFront are wrong answers. AWS Shield is a managed distributed denial of service protection service, and CloudFront is not specifically designed to prevent such web exploits. How can you safeguard your web application from DDoS or distributed denial of service attacks? You can use AWS Shield or Shield Advanced for this. AWS Shield is a managed distributed denial of service protection service that safeguards web applications running on AWS against common and large-scale DDoS attacks. This protection is available by default for free. AWS Shield Advanced is an optional paid service that extends the protection provided by AWS Shield with additional features such as advanced attack mitigation and cost protection against DDoS-related usage spikes. WAF auto-scaling groups and CloudFront can help with DDoS protection to a limited extent. AWS Shield remains the best way to solve this problem. So WAF, as we know, is used to prevent web exploits. It does allow setting rules for rate limiting and controlling the number of requests from specific IP addresses, geographic locations, or other criteria which can help mitigate the impact of certain types of DDoS attacks. Auto-scaling groups can help to some extent. For example, during a DDoS attack, if the existing instances are overwhelmed, auto-scaling can automatically launch additional instances to handle the increased load. Once the attack subsides, it can scale back in, reducing the resources to normal levels. The distributed architecture of CloudFront helps absorb and mitigate large-scale attacks by distributing the attack traffic across multiple edge locations, thereby reducing the impact on the origin server. Check for vulnerabilities on Amazon EC2 instances. For this, we can use Amazon Inspector, which is an automated vulnerability management service that continually scans EC2 and container workloads for software vulnerabilities and unintended network exposure. Although it primarily focuses on assessing the security posture of EC2 instances, it can also evaluate other AWS resources to a limited extent. AWS Security Hub aggregates security findings, and AWS Systems Manager Run command allows you to remotely execute commands on multiple EC2 instances. Both Security Hub and Systems Manager Run command are not suitable for this scenario. Monitor malicious activity in your account and generate security findings. For this, we can use Amazon GuardDuty, which is a threat detection service that continuously monitors for malicious activity and unauthorized behavior within AWS account. It analyzes CloudTrail logs, VPC flow logs, and DNS logs to detect threats such as unauthorized access, compromised instances, and port probing. Although marked as wrong answers, both AWS CloudTrail Insights and AWS Security Hub help us keep AWS accounts safe. CloudTrail Insights can detect unusual operational activity using CloudTrail logs, and AWS Security Hub aggregates security findings. A company uses many different AWS accounts, one per department. Over the years, several cross-account and public access of AWS resources has been mistakenly granted. How can the AWS administrator proactively identify security issues, and unintended access to the resources. For this, we can use AWS Access Analyzer. It continuously monitors your resource policies and access control policies, provides findings and recommendations to enhance security. AWS Access Advisor and AWS Security Hub are also helpful here, although neither of them is the best answer. AWS Access Advisor provides insights into service permissions granted to IAM roles, while Security Hub aggregates security findings and alerts from various services like GuardDuty, Inspector, Analyzer, etc. Provide full access to AWS services and resources, but without the permission to manage users and groups. So for this, we can use Power User Access Policy. So this policy is similar to Administrator Access Policy, but does not allow management of users and groups, while Administrator Access Policy grants complete control and management capabilities of all AWS services, including managing users and groups. Therefore, that is the wrong answer. And there is no such thing as a super user policy. Give AWS Console access to on-premise Microsoft Active Directory users. You can do this by setting up SSO or single sign-on with your on-premise Active Directory using AD connector. This allows your on-premise AD users to use their existing credentials to seamlessly sign in into AWS Management Console. Now, among the wrong answers, synchronize on-premise AD users with AWS Managed AD Service. We do not really need to set up a new AWS Managed AD Service and synchronize on-premise AD users. There is no need to do this. And register on-premise AD users as IAM users. This too is wrong because we do not want to duplicate existing AD users as IAM users. Can SSL certificate generated from AWS Certificate Manager or ACM for Application Load Balancer in one region be used in Application Load Balancer in another region? Answer is no. SSL certificate generated by AWS Certificate Manager is region specific and cannot be directly used in another region. So you must generate SSL certificate separately in each region where you intend to use it. How can we control access to PDF reports stored in a S3 bucket, ensuring access to specific reports via URLs only to paid users? For this, we can use S3 pre-signed URLs. A pre-signed URL uses security credentials to grant time-limited permission to download objects from S3 bucket. By default, objects in S3 bucket are private. So you can dynamically generate pre-signed URLs for specific reports you want to provide access to and share them with your paid user. Configuring the S3 bucket for public access is the wrong answer here, because we do not want to grant access to our reports to everyone, but only to our paid users. A web application has premium static images hosted in a S3 bucket that are served over CloudFront. How can you give access to all the images in the bucket to select users, ensuring access URLs do not change? For this, we can use CloudFront signed cookies, which offers the ability to manage access to multiple content files without requiring URL alterations for each user. This method allows controlled access to the images while keeping the URLs consistent. CloudFront signed URLs is the wrong answer here because it is designed to restrict access to individual files, requiring URL modifications for each user's access. So this method is less suitable for granting access to multiple files without changing URLs for each user. How can you restrict access to your application, which is hosted on EC2 servers behind an application load balancer, so that users from specific countries or geographic locations are unable to access it? We can do this using AWS WAF or Web Application Firewall, or CloudFront, or Route 53. Implementing a custom solution with IP address checks might involve manually maintaining a list of IP addresses associated with various geographic locations. This method requires continuous updates to the IP database and therefore is less effective and scalable. Therefore, it is not a good solution. How would you connect two VPCs? You can use VPC peering for this. VPC peering establishes a network connection between two VPCs, enabling communication and resource sharing between them as if they were part of a single network, while still allowing separate control over each VPC. This does not require an internet gateway, VPN, or hardware to establish the connection. The CIDR blocks of the peered VPCs must not overlap to avoid routing issues. Both Transit Gateway and Site-to-Site VPN are not the right solutions here. Transit gateways are typically used to connect several VPCs via a single gateway, simplifying networking between them, while Site-to-Site VPN is encrypted connection between on-premise network and AWS VPC. Let's look at various network connectivity types and their key features. VPC peering. This is a private connection between two VPCs. Transit Gateway is a centralized hub for connecting multiple VPCs, VPNs, and on-premise networks. It has a hub and spoke architecture. Direct Connect is a dedicated private network connection between on-premises and AWS Cloud. It provides low latency and high bandwidth connection. Site-to-Site VPN is encrypted connection between on-premises network and AWS VPC established over the internet. It provides secure communication using IPsec protocol. VPC A is paired with VPC B. VPC B is paired with VPC C. Can resources in VPC A reach VPC C? Answer is no. VPC A cannot communicate with resources in VPC C as there is no direct peering between them. Each peering relationship is independent and there is no transitive peering. To enable communication between resources in VPC A and VPC C, a separate peering connection between VPC A and VPC C would need to be established. Access S3 bucket or DynamoDB from a VPC without going over internet. For this, we can use gateway endpoint. Without a gateway endpoint, our requests from VPC to S3 or DynamoDB would travel over public internet. So gateway endpoint ensures that this does not happen and all communication happens over AWS infrastructure. Interface endpoint is a wrong answer here. Interface endpoint enables private connectivity to many services over AWS private link. These services include some AWS managed services, services hosted by AWS customers, partners, and so on. S3 is one of the supported service here, but not DynamoDB. Therefore, this is a wrong answer. VPC peering is clearly a wrong answer because it's meant to connect two VPCs. Let's look at various endpoints. Gateway endpoint. This provides secure private connection to Amazon S3 or DynamoDB from within a VPC. Data does not go over public internet. Interface endpoint. This too provides secure private connection to many services powered by AWS private link. These include AWS services or those hosted by AWS partners. So what is AWS private link? It provides private connectivity between VPCs, supported AWS services, and your on-premises networks without exposing your traffic to the public internet. Allow EC2 instance in a private subnet of a VPC to access internet. So by default, an EC2 instance in a private subnet does not have internet connectivity. Now we can provide this by using a NAT instance or a NAT gateway. Gateway endpoint and interface endpoint are wrong answers here. Gateway endpoint provides private connectivity to S3 or DynamoDB, while interface endpoint provides private connectivity using AWS private link to various services. So let's go over the difference between NAT instance and a NAT gateway. So NAT instance is a user managed EC2 instance for NAT. You must provision it manually and it can be a single point of failure. While NAT gateway is a fully managed AWS service which is highly available and suitable for production loads. Allow an EC2 instance in a private subnet to access only one particular URL, for example, to download a patch. Beyond this one particular URL, there should be no other access to internet. So for this, we can use a NAT gateway. This will provide the necessary internet connectivity. The subnet route table should be updated to use the NAT gateway, and the EC2 security group can restrict access to a specific IP. So this solves our problem. Route 53 is clearly a wrong answer here because it is a DNS management service. Your application running on EC2 instance in a private subnet needs to send data to Kinesis data streams privately, not over the internet. So what network configuration is required for this? So for this, we need to set up a VPC interface endpoint for Kinesis data streams in the VPC. Ensure that route table associated with the subnet has a route entry for the interface endpoint. And of course, interface endpoint policy should allow appropriate access permissions. Gateway endpoint is clearly a wrong answer here because that's for accessing S3 or DynamoDB privately. You have set up one EC2 instance in availability zone 1, 3 EC2 instances in availability zone 2. Application load balancer is set up in front of them. With cross-zone load balancing enabled, what percentage of requests go to each instance? Now, when cross-zone load balancing is enabled, traffic is distributed across EC2 targets. Since we have 4 EC2 instances in total, each instance gets 25% of the traffic. So what happens when cross-zone load balancing is disabled? In that case, traffic is distributed by availability zone. So in such a scenario, AZ1 will receive 50% of the traffic and AZ2 will receive 50% of the traffic. And since there is only one instance in AZ1, it will receive all of that 50% of the traffic. And since there are 3 instances in AZ2, the 50% of the traffic coming to it would be distributed across the 3 instances. Multiple VPCs need access to common or shared services and resources. For this, we can use Shared Services VPC, which is an architectural model whereby centralized services or resources are hosted within a dedicated VPC. Other VPCs establish connectivity to it through mechanisms like VPC peering or transit gateway. So this enables multiple VPCs to access common services securely while maintaining network isolation. Site-to-site VPN is for creating a secure connection from on-premise to VPC on AWS cloud. And Route 53 is a DNS management service. So both these answers are incorrect. Manage DNS configuration for internal resources within a VPC. For example, a DB server must be reachable via a name like prod.db.example.com. So how would you achieve this? We can use private hosted zone for this. A private hosted zone in AWS Route 53 is a feature that allows users to create and manage custom domain names for internal resources within a VPC. It enables private DNS resolution within the VPC, keeping domain name resolution restricted within the specified VPC boundaries without public accessibility. Using a custom DNS server may be possible, but it would require manual configuration and administration. There is no need to do this. Therefore, this is a wrong answer. A company has several remote branch offices in different places. All of them need to securely connect with each other and to a VPC in one region. What is the best way to do this cost efficiently? So for this, we will create a VPC private gateway in our VPC. Then each branch office uses a site-to-site VPN connection to connect to the VPC private gateway. So this hub and spoke architectural model is called VPN Cloud Hub. So all our remote branch offices are connected over VPN to the VPC private gateway in our VPC. Now, if a particular branch office needs high speed, high bandwidth connectivity to the AWS cloud or our VPC, it can use a direct connect connection to the VPC private gateway instead of VPN. Now here we are dealing with a single VPC. What if there were multiple VPCs which the remote branch offices must connect to? In that case, we must use a transit gateway instead of private gateway. A VPC private gateway is always attached to a single VPC. Allow private access to a S3 bucket only from resources in a specific VPC. So we can do this first by creating a gateway endpoint for S3. This will ensure that S3 can be reached privately, not over the internet. Next, create a S3 bucket policy and here restrict access to resources from a particular VPC only. VPC private gateway is a wrong answer here, since a VPC private gateway facilitates secure and encrypted connectivity between the VPC and external networks by using VPN or Direct Connect. So that does not help in our use case here. Migrate MySQL to PostgreSQL database. We can do this using AWS Schema Conversion Tool or SCT and Database Migration Service DMS to migrate database schemas and replicate data from source to target database one time or as ongoing real-time data replication. Writing glue job or custom scripts are wrong answers. Glue job is an ETL process and not well suited for this work, and there is no need to write custom scripts as we have better solution. Gaming data is being stored in DynamoDB. How can we improve DynamoDB read performance for creating gaming leaderboards? For this, we can use DynamoDB Accelerator, which is a high-speed distributed in-memory cache for DynamoDB that can significantly reduce read latency for frequently accessed data. Now, between Elasticache and DynamoDB Accelerator, DynamoDB Accelerator is the better choice here because our underlying database is DynamoDB and the DynamoDB Accelerator is seamlessly integrated with it. Therefore, Elasticache is not the best answer here. And Amazon Elasticache supports multiple caching engines, and one of those engines is Redis. Therefore, Redis 2 is not our best answer. What is an efficient way to delete all data in a DynamoDB table? We can drop the table and recreate it. Deleting an entire DynamoDB table is the most efficient way to remove all data at once. It's quicker than deleting items individually, especially when dealing with large data sets. Searching and deleting all items in a table is comparatively inefficient. How can we ensure high availability and fault tolerance with RDS? For this, we can set up RDS with multi-AZ configuration. In this setup, RDS replicates your primary database to a standby instance in a different availability zone within the same region. If the primary instance fails, the system automatically fails over to the standby, thereby reducing downtime and ensuring data durability. This setup enhances reliability by maintaining a synchronized standby database for failover purposes. Let's look at other options. RDS read replicas are asynchronous copies of the primary database. They help distribute read traffic, improve read performance, and provide scalability for read-intensive applications. They do not directly provide high availability and don't support automatic failover. Their focus is to improve read performance. Therefore, this is not a correct answer. Amazon Aurora is a high-performance relational database from Amazon. We do not need to migrate to it just for high availability. We already have a solution in RDS. Therefore, this too is not a correct answer. DynamoDB throttles at certain times of the day because of variable workloads. How can you handle this cost effectively? We have three options here. Use dynamic capacity provisioning, or increase provisioned capacity, or use DynamoDB Accelerator. Dynamic capacity provisioning is the best option here, where the provisioned read and write capacity units of DynamoDB is adjusted based on workload fluctuations. Now, since our workloads are not consistently high, increasing provision capacity is not required and is not cost effective. DynamoDB Accelerator can help with reducing throttling, but is not cost effective, therefore not the best solution here. In a globally distributed application spanning multiple regions that requires rapid read access to a relational database, which database is most suitable? Amazon Aurora Global Database offers read replicas across regions, making it suitable for globally distributed applications. Therefore, this is the right answer. Amazon RDS lacks the inherent global replication features and low latency access specifically tailored for distributed setups. Therefore, this is not the correct answer. And DynamoDB is a NoSQL database service provided by AWS. While DynamoDB excels in scalability, it's not a relational database and therefore does not fit the requirement. How can you collect information on servers and applications running in your on-premise environment in order to plan for migration to AWS? For this, we can use AWS Application Discovery Service. It collects information on on-premise servers, applications, and their dependencies. AWS Migration Hub is used to track application migration process. Therefore, this is not a correct answer. And AWS Application Migration Service, as the name suggests, is a migration service and is not a discovery service. Let's look at various migration services. AWS Application Discovery Service. This collects information on servers, running processes, network connections in your on-premise environment using agents, collectors, etc. AWS Migration Hub. This is a tracking service. This provides centralized tracking of application migrations. AWS Migration Service. This helps migrate servers, applications to AWS Cloud from your on-premise environment or from other cloud providers. You can also migrate EC2 workloads across regions, availability zones, or accounts. It ensures continuous synchronization between the source and target environments during the migration process and creates EBS volumes during this process. So this is a lift and shift migration strategy with little or no downtime. Next we have VM import export. Here we can import VM images from an existing environment to Amazon EC2 and also export them back to your existing on-premise environment. This does not provide live synchronization but is an offline process. You can also use it to create a repository of VM images for backup and disaster recovery purposes. What is the most suitable method to transfer 50 terabytes of data from an on-premise network to the AWS cloud within a few days, considering the existence of a site-to-site VPN between the on-premise network and the AWS cloud? So for this, we can use Snowball Edge, which is a physical device designed for large-scale data transfers to AWS. It's ideal for transferring massive amounts of data quickly by passing bandwidth limitations of a VPN connection. Given the 50 terabytes volume and time constraint, Snowball Edge physical transfer offers the most efficient solution. AWS Data Sync is a service for online data transfer between on-premise storage and AWS. But transferring 50 terabytes over a VPN connection might not be efficient within the specified time frame due to limitations in bandwidth. Therefore, this is a wrong answer. Snowmobile is meant for exabyte scale data and involves massive scale transfer via a large physical device, making it impractical for a 50 terabyte transfer within a few days due to logistics, scale, and costs. Therefore, this too is an incorrect answer. So we have the Snow family of devices which support offline transfer of data to AWS. Okay, so first we have Snow Cone. This has a capacity of about 8 terabytes. Then we have Snowball Edge. It comes in multiple flavors, storage optimized and compute optimized. So the storage optimized one provides about 80 terabytes of HDD space. And then we have Snowmobile. So this supports exabyte scale data transfer in a truck and has a capacity of 100 petabytes. We need to move 50 terabytes of data from an on-premise location to AWS cloud within a week. A high-speed 10 Gbps direct connect link exists between the networks. What is the most efficient way to do this? For this, we can use AWS Data Sync over Direct Connect, as it leverages the existing high-speed direct connect connection efficiently, ensuring the data transfer of 50 terabytes is within the given time frame of 7 days. Both AWS Snowball Edge and Snow Mobile are excessive for this particular scenario and could introduce unnecessary complexity and time. Therefore, they are not correct answers. How can you create a synchronized backup solution for an on-premise NFS server to Amazon EFS in the cloud? We have two options here, AWS Data Sync and AWS File Gateway. Let's look at them one by one. AWS Data Sync is designed explicitly for efficient and automated data synchronization between on-premise storage and AWS storage services like Amazon EFS, S3, etc. Therefore, this is suitable for a synchronized backup solution to EFS and is the correct answer. AWS File Gateway is primarily dedicated to enabling on-premise applications to access cloud storage, particularly S3, through NFS. While it facilitates data synchronization from on-premise NFS servers to the cloud, however, it lacks native support for synchronizing data directly with Amazon EFS cloud storage. Therefore, this is not the correct answer. Move on-premise application to AWS quickly without making changes and with minimal effort. This kind of migration would be called rehosting, which is a lift and shift migration. And this is the correct answer. Replatform is when we optimize our application to leverage some AWS services when we migrate. And refactor is when we make significant changes to our application by restructuring or redesigning. Since our requirement is to migrate without making changes, rehosting is the correct answer and replatform and refactoring are incorrect answers. How can we efficiently and quickly scale our on-premise web server which hosts publicly accessible PDF reports to accommodate a surge of millions of users expected during an upcoming marketing campaign? To efficiently handle the anticipated surge in users downloading PDF reports from our on-premise web server, we can set up an AWS CloudFront distribution with the on-premise web server as the origin. CloudFront can cache the PDF reports, ensuring quicker and more efficient download for users. Therefore, using CloudFront is the correct answer here. Migrating the web server to cloud might be an excessive step when the objective can be achieved more efficiently by leveraging CloudFront for caching purposes. Therefore, that is not the correct answer. EC2 instances of your autoscaling group are abruptly terminating for unknown reasons. You want to log into these EC2 instances before they are terminated to download logs and investigate. How can you do this? For this, you can use autoscaling groups lifecycle hooks. Now, Amazon EC2 autoscaling incorporates lifecycle hooks, allowing a designated time frame, typically 1 hour, for actions to finish before instance transition, in this case before instance termination. So when a scaling event happens, a lifecycle hook temporarily halts instance termination, sending an Amazon Event Bridge notification. And during this pause, you can connect to the instance to retrieve logs or investigate prior to the instance termination. Using Amazon CloudWatch events is the wrong answer, because CloudWatch events won't assist in pausing instance termination, which is essential in this scenario. They are more focused on monitoring and triggering actions based on events in an autoscaling group. An application supports uploading video files to API Gateway. However, it occasionally fails with error code 413 returned by API Gateway. How can we resolve this problem? Now, error code 413 indicates upload file size is too large. API Gateway does not support uploads greater than 10 MB. Therefore, we must make some changes to our architecture to handle this. Using pre-signed URLs, we can upload files directly to S3, where the upload size limit is much higher. Therefore, this is our correct answer. Changing API gateway file upload limit is not possible because this is not something that is configurable. Therefore, that is the wrong answer. How can we ensure uninterrupted service for in-flight requests when an instance operating behind a load balancer is being deregistered or taken out of service? For this, we can enable connection draining on application load balancer. When an instance is marked for deregistration, example during a scale down event, connection draining, also known as deregistration delay, allows the load balancer to complete serving the in-flight requests to that instance before taking it out of service. Our second option of disabling instance termination is not good because it would hinder the scale down process of the auto scaling group. You have diverse structured and unstructured data for analysis. Where is the best place to store it for processing? The correct answer here is AWS Data Lake using S3, which is ideal for diverse data types. It offers scalable, cost-effective storage, accommodating both structured and unstructured data for efficient processing and analysis. Both Redshift and DynamoDB are wrong answers here. Redshift suits structured data analysis, but it's less flexible and cost-effective for unstructured data or large-scale storage. DynamoDB is for structured operational data, not ideal for diverse or large volumes of structured and unstructured data intended for analysis. How would you analyze data in S3 using SQL queries? We can use Amazon Athena for this, which is a serverless interactive querying service that allows you to analyze data directly in S3 using SQL. It's designed for ad hoc querying and analysis of large-scale data sets. Let's look at Redshift Spectrum query. Redshift Spectrum is a feature of Amazon Redshift, a data warehouse service in AWS. Redshift Spectrum enables users to run SQL queries against data stored directly in Amazon S3 without needing to load it into the Redshift cluster. Now, our use case is simply to query and analyze data in S3, so bringing Redshift into the equation is not necessary. Therefore, this is not the best answer. AWS DMS or Database Migration Service is not meant for querying or analyzing data from S3. Therefore, it's not a correct answer. Let's go over some analytics services. Amazon Redshift is a petabyte scale data warehouse. Redshift Spectrum Query is a feature of Amazon Redshift which allows you to run SQL queries from Redshift directly against data stored in Amazon S3. Amazon Athena allows you to query data in S3 in an ad hoc manner using SQL. Amazon EMR is a managed Hadoop framework with support for Spark, HBase, Presto, and so on. AWS Glue allows you to create ETL jobs and also provides a Glue data catalog. QuickSight is a business intelligence and reporting tool. How should you organize IoT sensor data in your AWS S3 data lake for effective querying based on date? So you can partition the data by date and store it using Apache Parquet format. This approach enables efficient querying based on date because partitioning by date allows direct access to specific time frames, and using Parquet format enhances query performance due to its columnar storage and compression benefits. Now the second option, partition the data by sensor ID and store it in CSV format. This is not a good option. Partitioning by sensor ID might be helpful for specific sensor-based queries. It doesn't efficiently address the need for querying data by date. Additionally, storing data in CSV format could hinder query performance compared to using Parquet format due to CSV's lack of optimization for columnar storage and compression. Given that each department within a company uses its own RDBMS database, the company aims to consolidate all this data into a unified data warehouse for comprehensive, regular analysis. What would be the most cost-effective approach to achieve this goal. So for this, we can use DMS to replicate and synchronize data from various departmental RDBMS databases into Redshift, which is a specialized data warehousing platform for further data analysis. And the second option is to export all databases to Amazon Data Lake. This is not a good option because the question specifically asks for a data warehouse. What measures can a company take to ensure its encrypted at rest Redshift data warehouse is backed up in another region for disaster recovery? For this, broadly two steps are necessary. First is to enable cross-region snapshots so that Redshift snapshots are copied from one region to another. Next step is to create snapshot copy grant in the target region. Now, while doing this, we need to specify a KMS key. This key should be from KMS in the target region, as KMS keys are region specific. Therefore, the first answer where we specify KMS keys from the target region is the correct answer. The second answer is wrong because here we are specifying KMS keys from the source region. Medical records stored in an S3 bucket contain important patient information within the first 100 bytes of each file. What approach can efficiently retrieve this specific information from all files in the bucket? S3 Select with scan range parameter efficiently retrieves specific data from S3 objects without fetching entire files, making it perfect for getting the initial 100 bytes of each file. Therefore, this is the correct answer. Amazon Athena is designed for SQL-based querying of data in S3. It operates on entire objects rather than fetching specific bytes or portions of files. So this is not the right answer. And AWS Glue job is intended for ETL tasks and does not directly retrieve specific bytes from files in a S3 bucket. Therefore, this too is the wrong answer. How would you design an application on AWS to receive messages from various client devices and display visualizations in real time? So we can use AWS Kinesis data streams to receive messages from client devices in real time. And these messages would then flow into Kinesis Firehose, which acts as a delivery service directing the data to OpenSearch for storage and indexation. To visualize this data, Kibana can be used with OpenSearch, allowing you to create real-time visualizations and insights from the ingested messages. So this meets all the requirements of our scenario. Therefore, this is the correct answer. In the second approach, it is suggested that we use Amazon SQS to receive messages, Lambda for processing and storing data into S3, then visualize it using QuickSight. Here, using S3 as data storage and then QuickSight for visualization does not provide real-time visualizations the way the first approach does. Therefore, this is not the best answer. Let's go over some Kinesis services. Amazon Kinesis data streams. Ingest data streams at scale. Kinesis data firehose. Load data streams into data stores like S3, Redshift, OpenSearch, etc. Kinesis data analytics. For real-time analytics on streaming data. Kinesis video streams. Stream video from devices to AWS. DynamoDB has a lot of historical data that is only needed for analysis. How can we reduce the storage costs and perform ad hoc analysis on it? So we can export the DynamoDB data to S3 in compressed format and then delete historical data from DynamoDB. So storing the data in S3 is going to reduce our storage costs. And we can use Amazon Athena to query and analyze the data in S3 as needed. So this is our correct answer. Our second option is to move DynamoDB data to Redshift using ETL jobs. Now, moving NoSQL DynamoDB data to relational data store like Redshift using ETL jobs is unnecessarily complex without any real benefits. Therefore, this is the wrong answer. You are running Oracle database on an on-demand EC2 instance. Same database will continue to be in operation for several years. How can you reduce costs? We can do this by using reserved EC2 instance, which offers significant cost savings compared to on-demand instance for long-term predictable workloads like our Oracle database. Spot instances are significantly cheaper than on-demand instances, but they are not suitable for long-term consistent workloads. They can be interrupted for various reasons, which makes them unsuitable for a multi-year continuous operation where uptime is crucial. Therefore, using spot instances is the wrong answer. Our third option is to migrate to RDS. The question specifically states that same database will continue to be in operation for several years. Therefore, migrating to RDS is not indicated here. Hence, this is not the correct answer. Let's look at various EC2 instance launch types. On demand, available immediately without long-term commitment. Reserved, they provide significant cost savings for committed usage. Spot instances, available at lower costs from unused capacity, and they can be taken away anytime. Dedicated host, physical servers dedicated solely for your use. Per host billing, you have control over EC2 placement and they can be useful for regulatory needs. Dedicated instances, these are instances on hardware dedicated to you. There is a per instance billing and you do not have control over instance placement. Change subnet of an EC2 instance. So this is not possible. You cannot change subnet of an EC2 instance. Instead, you can create an AMI from a EC2 instance and launch it in the desired subnet, in which case it is essentially a new EC2 instance. And the wrong answer is stop an instance and change the subnet. You cannot do that. How can you streamline and standardize the management of multiple AWS accounts across various company departments? For this, we can use AWS Organizations, which allows you to centrally manage and govern multiple accounts by creating a hierarchy, applying policies across the organization, and simplifying administrative tasks. Hence, this is our best answer. Cross-account roles are used to delegate access between AWS accounts securely. It's more about access control rather than centralizing management tasks across accounts. Therefore, this is not a correct answer. AWS Direct Connect is an obvious wrong answer. It is used for establishing a dedicated network connection between an on-premise network and AWS. It's not designed for managing multiple AWS accounts together. Let's go over some AWS organization related services. So the first is AWS Organizations. It is used to manage and govern multiple accounts centrally in a hierarchy. Next, we have Control Tower for automated setup for multi-account environments. Service Control Policies for enforcement of organizational policies. And Service Catalog. This is a catalog for approved AWS services. How can you prevent accounts in your AWS organization from launching EC2 instances without a specific tag? So for this, we can use Service Control Policies or SCPs in AWS organizations to enable the enforcement of rules across the organization's account hierarchy. So by attaching a SCP to the organization's root, you can mandate specific requirements such as tagging across all accounts within the organization. This ensures consistent compliance and control over EC2 instance launches. Using AWS config rule is incorrect in this context. While AWS config rules can monitor resource configurations for compliance, they don't directly prevent EC2 instance launches without specific tags. And Amazon CloudWatch alerts also don't directly prevent EC2 instance launches without tags. CloudWatch alerts are primarily used for monitoring and triggering actions based on specific conditions in your AWS environment. How can you create a centralized log of events that occur within an AWS organization and its member accounts? Let's first understand what is CloudTrail. AWS CloudTrail is an AWS service that logs and tracks API activity within an AWS account, providing detailed records of actions taken, helping with security, compliance, and troubleshooting. And Organization Trail centralizes event logging specifically for an AWS organization and its member accounts, offering comprehensive monitoring and tracking capabilities at an organization level. Therefore, our correct answer is Organization Trail and not CloudTrail. And CloudWatch Logs primarily captures logs from various AWS services, but it doesn't inherently centralize event logging for an entire AWS organization. You have deployed an application across various AWS regions to serve a global user base. How can you efficiently direct user traffic to a regional endpoint with lowest latency and swiftly reroute traffic if a regional endpoint fails? Both AWS Global Accelerator and Route 53 can route end user traffic to a regional endpoint based on lowest latency, and in case of a failover, reroute traffic to a healthy endpoint. However, there is a difference in terms of how quickly failover routing happens. With Global Accelerator, this failover is quick. With Route 53, there may be a delay because of the way DNS works and how its changes are propagated. Therefore, AWS Global Accelerator is the better choice in this scenario. CloudFront doesn't explicitly offer similar capabilities. It's primarily focused on delivering cached content quickly to end users from its edge locations. Therefore, it is not the correct answer. Let's go over some routing services. Elastic Load Balancer. There are many kinds of these. Application Load Balancer, which is suitable for web application traffic and does not support static IP address. Network Load Balancer. This can be used when you want to directly work with TCP or UDP traffic, and it supports static IP address. Classic Load Balancer. This is legacy and no longer recommended for use. Gateway Load Balancer for virtual appliances. API Gateway. It is used to route requests to APIs based on rules. It supports stateless secure HTTP and REST APIs and stateful WebSockets protocol. CloudFront is a content delivery network and it can cache content at the edge. Using Lambda at Edge feature, you can run Lambda functions at the edge locations. Global Accelerator. It utilizes static Anycast IP addresses to direct traffic over AWS Global Network. It supports rapid failover by dynamically rerouting traffic to healthy endpoints within seconds. Route 53 is a DNS management service and it supports DNS-based failover, which may encounter some delays due to DNS caching. How can you ensure that an application service running on EC2 instances behind an application load balancer can be accessed by multiple clients that require a fixed or static IP address to invoke the service? As per our scenario, application load balancer is the entry point for a service, and assigning a static IP address directly to an application load balancer isn't possible. So to ensure a fixed IP as entry point into our application, we can introduce a network load balancer preceding the application load balancer. A network load balancer can have a static IP address. So that's our correct answer. Using CloudFront is incorrect here, since CloudFront operates through a distributed network of edge locations and doesn't provide a singular static IP address for exposure or use. A multiplayer gaming application hosts game servers on various EC2 instances. How can we ensure that players in a particular game session always connect to their designated gaming server or EC2 instance? For this, we can use Custom Routing Accelerator, which empowers you to apply your custom logic for directing users to a particular Amazon EC2 destination. Now, this capability maintains the advantages of Global Accelerator while granting increased control and flexibility in managing traffic distribution. Therefore, this is our correct answer. Route 53, on the other hand, excels in DNS-based routing but does not offer the same low-level control and optimizations as the Custom Routing Accelerator for managing traffic within the AWS network at a deeper level. Therefore, this is not the correct answer. How can we structure our solution to ensure that requests for specific subdomains are directed to the corresponding ECS clusters catering to each service? So for this, we can set up an application load balancer to direct requests to the relevant ECS cluster by leveraging host-based routing. So request for support.example.com is routed to the support target group. The support ECS cluster would be associated with this particular target group. Next, we will configure Route 53 to manage the main domain example.com and use a wildcard entry like star.example.com to direct all subdomain requests to application load balancer. So support.example.com, app.example.com and web.example.com gets routed through the application load balancer for further processing and allocation to the correct ECS cluster. So that was our best answer. Here's another approach. We can use individual application load balancers for each subdomain and assign corresponding ECS cluster to receive requests from it. And in Route 53, create entries for each subdomain so that they point directly to their corresponding application load balancers. Now, this second approach can lead to unnecessary complexity and higher costs compared to a more consolidated approach discussed previously. So, this is not a good solution and therefore the wrong answer. You have an AWS hosted web application with application load balancer as the entry point. The deployed application and code cannot be changed. So how can you dynamically modify the login page delivered to end users based on device type they are using? For this, we can employ CloudFront with Lambda at Edge function to dynamically adjust the login page according to the device type from which it is requested. So Lambda at Edge extends the capabilities of AWS Lambda to the edge locations of Amazon CloudFront, allowing you to run Lambda functions in response to CloudFront events. So this allows you to customize and enhance content delivery or security and user experience at the edge of the AWS network. The second approach of using API Gateway with Lambda functions to customize login pages dynamically is complex and not viable. Since this is a web application serving pages, using API Gateway is not warranted here. Therefore, this is the wrong answer. You have deployed a web application on an ECS cluster with application load balancer in front and CloudFront for caching on the edge. How can you ensure that application load balancer can be accessed only via CloudFront and not directly? So for this, we can add custom HTTP headers to requests that CloudFront sends to application load balancer. So you can configure your CloudFront distribution to do this. And then configure your application load balancer to only accept requests that contain these custom headers. So that's our correct answer. Now let's look at the second approach. Ensure that the application load balancer security groups restrict access only to the CloudFront IPs. Problem with this approach is that CloudFront IPs could change over a period of time. Therefore, this is not a viable approach and hence the wrong answer. In a gaming application that uses UDP and is deployed across multiple regions, global game players connect to the nearest healthy regional endpoint for optimal latency. How can we establish a fixed IP address as the entry point into the gaming application? AWS Global Accelerator provides a pair of static Anycast IP addresses that act as a fixed entry point, routing traffic through the AWS Global Network to your gaming application's regional endpoints. So that's the best solution for this scenario. Let's look at the second option. Configure Route 53 to map a domain name to elastic IP addresses of regional endpoints. While this may be feasible, but it is not the most optimal solution for the given scenario, as we are looking for a direct fixed IP address for this global application. You are rolling out a new version of your e-commerce application on AWS and aiming for fast yet controlled transition for your users from the old to the new version. Both the versions of the application will continue to exist and serve users until all users have been transitioned. How would you manage this transition effectively? For this, we can use AWS Global Accelerator and Blue-Green Deployment Strategy. So, with AWS Global Accelerator, implementing a blue-green deployment strategy becomes seamless. It allows for smooth transition and precise control over distribution of user traffic between your existing blue and new green deployments of your application. Therefore, this is our correct answer. Let's look at the second option of using Route 53. Route 53 relies on DNS-based routing and faces challenges with DNS caching, causing potential delays in propagating changes during blue-green user traffic transition. Therefore, it doesn't offer the granular traffic management for swift transitions between environments like AWS Global Accelerator does. Hence, it is the wrong answer. As an account administrator, how can you track configuration changes in your account over a period of time and monitor it for compliance? So we can use AWS Config for this, which provides compliance monitoring and config change tracking. AWS Systems Manager is for unified resource management and automation of operational tasks, patching, etc. And AWS Control Tower is for automated setup for multi-account environments and centralized account management within AWS organizations. Therefore, Systems Manager and Control Tower are not the right answers. Let's go over some AWS config and monitoring services. AWS config, audit config changes and compliance. Systems Manager, centralized ops data and automation. Resource Access Manager, share AWS resources across accounts. CloudWatch, monitoring logs, metric collection and alarms. CloudTrail, records AWS API activity for auditing of resource changes. AWS X-Ray, request tracing. How would you automate common maintenance and deployment tasks across a fleet of EC2 instances? You can use AWS Systems Manager agent for this. So install AWS Systems Manager agent on these EC2 instances, using which you can centrally manage and automate various operational tasks on your EC2 instances. So that's our correct answer. Amazon Inspector is a security assessment service. For example, you could use it to find vulnerabilities on EC2 instances. And AWS Config is for evaluating and auditing configuration of AWS resources like EC2 instances. Therefore, both Amazon Inspector and AWS Config are wrong answers here. How can you address the issue of some clients overloading the company's system by making an excessive number of API calls through Amazon API Gateway REST API? We can solve this problem by implementing per client throttling limits in API Gateway and utilizing API keys as client identifiers. This allows you to control and limit the number of requests each client can make, thus preventing system overload. And this is our chosen solution. AWS X-Ray primarily focuses on providing insights into application performance by tracing requests as they move through various services. Therefore, this is not an optimal solution for the given scenario. A company has many resources which may be idle, underutilized, or unsecured. How can it generate actionable recommendations to optimize cost, security, and performance? For this, we can use AWS Trusted Advisor, which provides actionable recommendations for optimizing cost, security, performance, and fault tolerance. AWS Cost Explorer, on the other hand, focuses mainly on cost management and analysis. And AWS Config monitors configuration changes but doesn't directly offer actionable recommendations for optimizing cost, security, and performance. Therefore, AWS Trusted Advisor is our chosen solution and not Cost Explorer or AWS Config. How can a user securely access and log into an Amazon EC2 instance without relying on SSH key pairs or access keys. For this, we can use AWS Systems Manager Session Manager. It provides secure, auditable, and remote shell access to your Amazon EC2 instances without requiring open inbound ports or SSH keys. It allows you to connect to instances directly from the AWS Management Console or through the AWS CLI. Therefore, this is the correct answer. Our second option is to use AWS Systems Manager run command. Now that allows you to execute commands on one or more EC2 instances remotely without the need for SSH or access keys. Since our question pertains to logging into EC2 instance and not running commands remotely, this is not the right answer. How would you trace user requests through your application and visualize them to understand how your application and its underlying services are performing? For this, you can use AWS X-Ray, which helps developers track and understand how requests flow through their applications, giving insights into performance issues, if any, within distributed systems. AWS CloudTrail doesn't trace flow of requests within an application, but rather tracks API level actions and changes made to AWS resources. Therefore, this is not the correct answer. AWS CloudWatch is a monitoring and logging service. Tracing requests is not a native feature of the service. Therefore, it is not the correct answer. Capture all IP traffic flowing to and from a VPC. To monitor and capture inbound and outbound IP traffic within a VPC, VPC flow logs can be employed. This feature captures data regarding IP traffic that traverses network interfaces within the VPC. The collected log data can be directed to Amazon CloudWatch logs or stored in Amazon S3. Neither Amazon CloudWatch nor AWS X-Ray is designed for this specific purpose. Amazon CloudWatch lacks the capability to independently capture this type of traffic, while AWS X-Ray traces API calls within an account. It does not capture IP traffic. Seamlessly monitor network traffic in near real time on an EC2 instance for suspicious activities or security threats continuously without disrupting the EC2 instance. For this, we can use traffic mirroring. Here we mirror traffic from the source EC2 instance to a target EC2 instance and run network monitoring tools on the target EC2 instance or appliance. Amazon Inspector is a wrong answer here because it does not monitor traffic directly on the EC2 instance, although it helps us find vulnerabilities on the EC2 instance. And VPC flow logs can capture network traffic information and send the logs to CloudWatch or S3, where it can be analyzed further. However, it is a wrong answer because it is not a real-time solution. How do you leverage Chef or Puppet to automate AWS resource configuration and application deployment effectively? For this, we can use AWS OpsWorks. OpsWorks streamlines the management of AWS resources and automates application deployment by utilizing Chef or Puppet as its core configuration management engines. So this is our correct answer. Let's look at other options. CloudFormation. Now, the question scenario specifically focuses on using the automation platforms of Chef or Puppet for resource configuration and deployment. Whereas CloudFormation's primary strength lies in infrastructure provisioning. Therefore, this is not the correct answer. Our third option is CodeDeploy, which is excellent for automating application deployments on AWS, but doesn't offer the detailed configuration management capabilities of Chef or Puppet. And therefore, this is the wrong answer. Roll out new features or changes gradually to a subset of users or servers before the full deployment. For this, we can use Canary deployment, which is a progressive rollout of an application to a subset of users before rolling out fully. Our second option is Blue-Green deployment strategy. This is not a progressive rollout. Therefore, it is not the right answer. Let's discuss some deployment strategies. Canary. This is an incremental or progressive rollout of new features or updates to a small subset of users or servers. A/B testing. Here we perform split testing of two versions of something like a web page, app feature, etc. to gauge which version performs better. Blue-green. Here we maintain two environments, blue and green. And then we can release new version of our application on green environment and switch traffic from one environment to another to perform our tests. How can you architect a solution for an on-demand video streaming platform? The video files are stored in a S3 bucket. The service should support dynamically adjusting video quality in real time for different bandwidths and devices, while ensuring optimal playback across varied formats. So for this we can use AWS Elemental Media Convert, which transcodes video files to support various formats and adaptive bitrate streaming. And CloudFront caches and distributes the content globally. So that's our solution. Let's look at other options. MediaLive is geared towards live video processing and streaming. It's primarily used for encoding and streaming live video content to various devices. However, our use case is on-demand video streaming platform, which works with video files. Therefore, MediaLive is not the correct answer. Amazon Connect is a cloud-based contact center service which allows you to set up and manage customer contact centers efficiently to handle calls, chats, and so on. It does not support video streaming. Therefore, it is the wrong answer. Let's go over some AWS media services. AWS Elemental Media Convert. This is for file-based video transcoding. MediaLive is for live video processing and encoding. Media Package is for media content packaging. And Media Store is a durable media storage. Media Tailor is used for personalized ad insertion. And Amazon Interactive Video Service or IVS offers live streaming and interactive experiences. You have a large collection of images and videos in a digital media library. How can you organize and categorize the media files efficiently based on their content? For this, we can use Amazon Rekognition, which has comprehensive image and video analysis capabilities using machine learning and computer vision technologies. It can do object and scene detection, facial analysis, text detection, and so on. Therefore, it is suitable for categorizing the media files based on their content. Amazon Transcribe is not the correct answer. It is a speech-to-text conversion service. In other words, it transcribes audio files into accurate and time-stamped text. Let's go over some Amazon AI services. Amazon Rekognition. It's used for image and video analysis. Amazon Polly, text-to-speech conversion. Lex, for creating chatbots. Comprehend. It has natural language processing capabilities. So it can be used for sentiment analysis or key phrase extraction from text. Amazon Transcribe. Audio to text conversion. Amazon SageMaker. It's a platform for building, training, and deploying machine learning models. Amazon Personalize. Create personalized recommendations using ML algorithms. Textract. Extract text and data from scanned documents. Amazon Forecast. Generate accurate forecasts based on time series data using machine learning. For a smart city traffic optimization project using sensors at intersections to monitor traffic patterns and adjust signals in real time, which combination of AWS services ensures secure data transmission to the cloud, device security, and supports immediate response for traffic management? For this, we can use AWS IoT Core, IoT Device Defender, and AWS Lambda function. IoT Core acts as a message broker receiving messages from sensors. IoT Device Defender monitors the devices to ensure security. and AWS Lambda function processes the messages. Our second option is to use Amazon Kinesis data streams, Kinesis Data Firehose and S3. Although you can use Kinesis data streams to receive messages from sensors, it is always better to use AWS services which are purpose-built for a use case, like IoT Core in this case. And in this option, there is no specific provision for device security. Therefore, comparatively, this is not a good option. Let's go over some IoT services. IoT Core. It serves as a message broker and has other features like Rules Engine. IoT Device Defender. It monitors device behavior for security. IoT Device Management. It can be used for remote management of devices. IoT Greengrass. It extends AWS IoT cloud capabilities to the edge. IoT Sitewise can collect industrial data and monitor operations. IoT Analytics is used for analyzing data from IoT devices. IoT Twin Maker. It is used for digital representation of physical devices. How would you manage syncing data in real time between users and the backend, as well as enabling access to data while offline? For a gaming app being developed for both mobile and web on AWS, we could use AWS AppSync for this, which provides a managed GraphQL service that automatically handles data synchronization across different devices and the backend, and also enables offline access through caching mechanisms. And this is useful for applications like chat applications, collaborative tools, gaming apps, or any application where multiple users need to interact with shared data in real time. Let's look at the second option. So here you could use WebSockets API Gateway 2, and it would work for this scenario. With WebSockets API Gateway, you have more granular control over the synchronization process. It allows direct control over WebSocket connections. However, unlike AppSync, the offline functionality is not a part of its core features and must be custom built. Therefore, comparatively, this may not be the best approach. You have a set of AWS Lambda functions written in Python that all require the same custom module for data processing. How would you optimize the deployment and maintenance of this shared module across these functions? We can use Lambda layers for this. Lambda functions can be set up to fetch supplementary code and content as layers, which are zip archives containing libraries, custom runtimes, or dependencies. These layers enable the utilization of libraries within the function without bundling them into the deployment package, thereby keeping the package size minimal. Our second option is to individually package the custom module with each Lambda function deployment. So, by duplicating the custom module across each function's deployment package, it increases the size of each function's deployment package unnecessarily and complicates the process of maintaining and updating the shared module across multiple functions. Therefore, this is not a good option. How can you increase the computing power allocated to your Lambda function? So for this, we must allocate more memory to the Lambda function. Now, remember that compute power to a Lambda function is allocated in proportion to the memory allocated to it. So, higher memory allocation automatically provides more CPU power to the Lambda function. Increasing timeout for the Lambda function doesn't help. So that's the wrong answer. How do we set up delayed visibility for messages sent to a SQS queue, ensuring they stay hidden for a specific duration before becoming accessible for retrieval? For this, we can add delay seconds attribute to a message. It introduces an initial delay before the message becomes available for any consumer to retrieve. Message visibility timeout attribute on a message controls how long a message stays invisible to other consumers after being retrieved by a consumer. This is not the correct answer because it refers to post-retrieval invisibility. Message retention in a SQS queue is the duration a message stays in the queue. After this time elapses, the message is automatically removed, ensuring queues do not retain messages indefinitely. How can we enable multiple consumers to efficiently read data from a shared Kinesis data stream shard without causing contention or performance issues? For this, we can use enhanced fanout feature. In a traditional fanout scenario, if consumers read data from a shared Kinesis shard, all consumers read the same data, and if one consumer falls behind or is slow, it affects others. Enhanced fanout, on the other hand, allows each consumer to read its own copy of the data independently from the same shard. This ensures that consumers don't impact each other. Therefore, using enhanced fanout is our chosen answer. Let's look at the second option of increasing the number of shards. As per our question scenario, multiple consumers need to access the same shared shard. Therefore, simply adding more shards won't really solve the problem. And hence, this is the wrong answer. Before you execute an operation, you need to find if you have necessary permissions, configurations, and the potential impact of executing the operation. How can you do this? For this, we can use AWS CLI command to execute the operation with a dry run flag. It performs simulation of the operation and displays the steps it would take to execute the operation, but stops short of applying any modifications to resources. It's a great way to validate permissions, configurations, and the impact of an operation before actually performing it. So that's our correct answer. Our second option is to use test run flag with AWS CLI. That is incorrect simply because there is no such thing as a test run flag. How can we effectively find detailed expenses by department in a company, given that each department operates its own distinct AWS accounts? For this, we can organize departments under AWS organization as organizational units or OUs, and then department accounts can be attached to corresponding OUs. Next, enable consolidated billing for the organization, and then use cost allocation tags to tag resources in each departmental account. So now, using AWS Cost Explorer or reports, we can analyze costs by department based on allocated tags. So that's our solution. Our second option is to use AWS budgets. AWS budgets primarily focuses on setting and monitoring budget limits and sending alerts based on those thresholds. It does not provide detailed expenses by department. Therefore, it is not the best answer. How would you build a cloud-based customer support service that incorporates both voice and chat communication channels? For this, we can use Amazon Connect, which is a cloud-based contact center service. It enables businesses to set up and manage customer contact centers without requiring complex infrastructure or upfront costs. Both Amazon Lex and Amazon Comprehend are incorrect answers. Amazon Lex is ideal for text-based interactions and chatbot creation, while Amazon Comprehend can extract valuable insights from large volumes of text data. It has natural language processing capabilities. Let's go over some sample questions now. So, how to tackle the questions? Read the question carefully. Identify key focus of the question. Read the answers carefully. Eliminate the wrong answers. And then zero in on the right answer. You are tasked with fortifying the security of a high-traffic e-commerce platform hosted on AWS. The goal is to mitigate common web vulnerabilities and secure sensitive customer data. Which combination of Amazon Security Services would best suit this scenario? So this question focuses on mitigating common web vulnerabilities and securing sensitive customer data. Option A. Implement AWS Shield Advanced for DDoS protection and AWS Web Application Firewall to safeguard against common web exploits and SQL injection attacks. So here AWS Shield Advanced provides protection against DDoS attacks. However, the question does not specifically refer to DDoS attacks. Using AWS Web Application Firewall is good here because it safeguards against common web exploits. And securing sensitive customer data is not directly addressed in this option. Therefore, this option appears to be incorrect. Option B. Utilize AWS Guard Duty for intelligent threat detection and Amazon Inspector for continuous assessment of security vulnerabilities within the application code. Here, although AWS Guard Duty offers threat detection and Amazon Inspector continuously assesses security vulnerabilities, this combination does not directly focus on mitigating common web vulnerabilities or encrypting sensitive customer data as required for an e-commerce platform's security. Therefore, this is not the correct answer either. Option C. Deploy AWS CloudFront with AWS WAF for content delivery and application level protection and AWS KMS for encryption of customer payment information stored in the database. So this option combines AWS CloudFront with AWS Web Application Firewall or WAF, offering protection at the edge for content delivery and application level security against common web exploits. Additionally, AWS KMS ensures encryption of sensitive customer payment information, meeting the requirement to secure sensitive data. So, this appears to be the correct answer. However, we still have the option D. Let's look at that. Employ AWS Security Hub for centralized security monitoring and AWS IAM for fine-grained access control over customer data access. While AWS Security Hub facilitates centralized security monitoring and AWS IAM controls access, this combination doesn't address specific measures for mitigating common web vulnerabilities or encrypting sensitive customer data. Therefore, this is not a correct answer. Hence, option C is our correct answer. You are designing a secure architecture for a healthcare application handling sensitive patient records on AWS. The requirement is to ensure compliance with healthcare regulations and protect patient data from unauthorized access. Which security solution would you suggest? So the focus here is on ensuring compliance and protecting patient data. Let's look at the options. Option A. Utilize AWS IAM for access control and AWS Key Management Service for encrypting patient records stored in Amazon S3. Here, while AWS IAM controls access and AWS KMS encrypts data, it does not focus on ensuring compliance with healthcare regulations. Therefore, this does not appear to be a good answer. Let's look at other options. Option B. Implement AWS Detective for threat detection and AWS CloudTrail for monitoring API activity within the application to ensure a secure application posture. This option does not focus on compliance or active protection of sensitive patient records. Therefore, this is not a good answer either. Option C. Deploy AWS WAF in conjunction with AWS Shield Advanced for DDoS protection and perimeter security. These are good security measures, but again, there is no focus on compliance or protecting sensitive patient records, which is a requirement for this healthcare application. Therefore, this does not appear to be a good answer either. Option D. Utilize AWS Macie for identifying and protecting sensitive data and AWS Config for continuous assessment of resource configurations against compliance rules. So AWS Macie helps us in identifying sensitive patient data and therefore protecting it. And AWS Config allows continuous evaluation of resource configurations against predefined compliance rules, ensuring adherence to healthcare regulations. Therefore, amongst the options presented, option D is the best answer. You are tasked with optimizing global content delivery for a high-demand media streaming service on AWS. This service streams live events to users worldwide, requiring low latency access and fault tolerance. Which combination of AWS services would best address the complexities of efficient global content delivery for this media streaming platform? So the focus here is on live media streaming and global content delivery. Let's look at the options. Option A. Implement AWS Elemental Media Live for live video encoding and AWS Elemental Media Package for content packaging utilizing Amazon CloudFront for global content delivery with customized edge caching. So here AWS Elemental Media Live provides us with real-time encoding, and media package can package the content for delivery. CloudFront's edge caching ensures low latency global content delivery. So overall, this solution meets the requirements laid out in the question. Hence, it is a good candidate for being a correct answer. Let's look at other options. Option B. Deploy Amazon Route 53 with latency-based routing and AWS Elemental Media Store for optimized content caching and delivery to global viewers. So here, while Route 53 facilitates latency-based routing, AWS Elemental Media Store focuses on storage rather than edge caching, making it relatively less suitable for optimized content delivery in a live media streaming scenario. Hence, this is not a good answer. Option C. Utilize AWS Elemental Media Connect for secure and reliable video transport and AWS Global Accelerator for optimized global routing of video streams to users. Media Connect manages secure video transport and Global Accelerator doesn't directly handle content delivery optimization. Therefore, this is not a good option. Option D. Implement AWS Direct Connect for dedicated network connections between regions and Amazon CloudFront with customized edge locations for optimized content caching and delivery. AWS Direct Connect is a dedicated high-speed network connection between an on-premise network and AWS Cloud. This has nothing to do with live media streaming to a global audience. Therefore, this is not the correct answer. Hence, we can conclude that option A is our correct answer. As an architect, you need to lay out a network design for a multinational gaming company launching a real-time multiplayer game hosted on AWS. The objective is to ensure low latency, high throughput connections for global gamers across various regions. Which AWS services would you choose to achieve this? So the focus here is on low latency, high throughput connections for global gamers in a real-time multiplayer game. Let's look at the options. Option A. Utilize AWS Direct Connect for dedicated private connections between the gaming company's data centers and AWS regions, paired with Amazon Route 53 for latency-based routing of gaming traffic. Our question scenario does not refer to any data centers, and using AWS Direct Connect is not meaningful here. Therefore, this does not appear to be a good solution. Let's look at other options. Option B. Deploy AWS Global Accelerator for optimized global routing and AWS Transit Gateway peering for management of network traffic between the gaming servers in different AWS regions. AWS Global Accelerator optimizes global routing for low latency access, while Transit Gateway peering facilitates efficient traffic management among gaming servers in various regions, ensuring high throughput connections crucial for a real-time multiplayer gaming solution. So this looks like a good answer. Let's look at other options. Option C. Implement AWS VPN for encrypted connections between the gaming company's offices and AWS regions, leveraging AWS Global Accelerator for optimized global routing of multiplayer gaming traffic. Reference to company's offices is misleading here, as the question scenario has no reference to it. Therefore, this is not the right answer. Let's look at option D. Utilize Amazon CloudFront for content delivery and Amazon Route 53 with geolocation routing to direct gaming traffic to the nearest AWS regions hosting the gaming servers. CloudFront assists with content delivery but might not be specialized for gaming traffic going to the servers. And Route 53 is for DNS-based routing and cannot reroute traffic quickly as may be required in a real-time multiplayer gaming solution. Therefore, option D is not the right answer. So option B, where we use AWS Global Accelerator and AWS Transit Gateway peering, is our best answer. In designing a robust network infrastructure for an expanding e-commerce platform on AWS, you aim to segregate development, testing, and production environments securely. Which configuration of AWS VPC networking best aligns with these requirements? So here the focus of the question is on segregating development, testing, and production environments. Let's look at the options. Option A, set up a single VPC with distinct subnets representing development, testing, and production environments using security groups and network ACLs to manage inter-subnet traffic. While this appears to be a viable option, let's see if we have better ways to isolate these environments. Option B, deploy individual VPCs for each environment and establish VPC peering connections to regulate communication and employ security groups for traffic control. Using separate VPCs for distinct environments ensures network segregation. VPC peering facilitates secure communication between them, and security groups add an extra layer of control over inbound and outbound traffic, thereby meeting the needs of a secure and segregated environments. This is better than option A and probably the right answer. However, let's look at other options. Option C, utilize a single VPC with unique security groups for each environment, ensuring isolation across different availability zones for secure communication. So, although using one VPC with distinct security groups across availability zones might provide some isolation, it does not match the security standards and isolation achieved by separate VPCs. Therefore, this is not the best answer. Let's look at option D. Create separate VPCs for each environment and establish VPN connections leveraging AWS Transit Gateway for managing traffic flow and secure inter-VPC communication. Creating separate VPCs and using VPN connections with Transit Gateway introduces complexity and might not be as straightforward as VPC peering for secure inter-environment communication. Therefore, this is not a good option. Hence, option B of using separate VPCs for each environment and VPC peering between them along with security groups is the right answer. You are architecting data infrastructure for a media streaming platform on AWS, aiming to efficiently manage metadata and user profiles while saving media files in a scalable, cost-efficient manner. Updates to metadata may be streamed in real time to other services for analysis. How would you fulfill these requirements, ensuring high performance and scalability? So here we focus on managing metadata and user profiles, and also updates to metadata may be streamed in real time to other services. We also need to save media files in a scalable, cost-efficient manner. Let's look at the options. Option A, utilize Amazon RDS for managing metadata and user profiles, and leverage Amazon S3 for scalable storage and retrieval of media files. RDS is effective for managing metadata and user profiles. Leveraging S3 for media files may offer scalability and is cost-effective. However, streaming the changes to metadata which is stored in RDS is a challenge here. So this may not be the best option. Let's look at option B. Implement Amazon DynamoDB for storing metadata and user profiles, paired with Amazon S3 for storing and efficiently accessing the media files. DynamoDB offers high scalability and performance for storing metadata and user profiles, while S3 provides scalable and cost-effective storage for media files. Since the metadata is in DynamoDB, DynamoDB streams can be used to stream the changes in data to other services. Therefore, this appears to be a good answer. Let's look at other options. Option C. Store metadata and user profiles in DynamoDB, and media files can be saved to Amazon FSx. So here DynamoDB for metadata and user profiles is a good option. However, Amazon FSx may not be as cost effective as S3, especially in the long term, given that it provides many storage classes. Therefore, this is not the best answer. Let's look at option D. Utilize Amazon Redshift for managing metadata and Amazon EFS for storing media files, allowing Redshift Spectrum to perform analytics directly on EFS. Redshift is a data warehouse and not suitable for storing and streaming real-time data. And for this use case, storing media files in S3 is better than storing them in EFS. Therefore, this is not a good option. Hence, option B of using DynamoDB and S3 is our best answer. A ride-sharing application on AWS aims to process and analyze incoming location data from drivers and passengers. The application requires rapid data ingestion, real-time analysis, processing, and also long-term cost-efficient storage for further analysis of ride patterns. As a solution architect, how would you meet these requirements? So the focus here is on rapid data ingestion, real-time analytics, and long-term cost-efficient storage of the data for further analysis. Let's look at the options. Option A. Deploy Amazon Kinesis data streams for data ingestion and processing and then store the data in S3. Use AWS Glue for transforming and analyzing the data in real time and long term. So using Kinesis data streams for rapid data ingestion is good, and so is storing data in S3, which is cost efficient and scalable. However, AWS Glue is not a good option for real-time analytics. We need to find a better solution. So let's look at the option B. Implement Amazon Kinesis Data Firehose for data ingestion and direct the data to Amazon Redshift for real-time analytics and historical data storage to predict demand patterns. So Kinesis Data Firehose simplifies data delivery to Redshift. However, using Redshift for real-time analytics is not good. We need to find a better way to do this. Let's look at option C. Ingest data into SQS and use Lambda functions to save it into S3. Use Amazon Athena to query and analyze data in S3 quickly. Now here, Amazon Athena can be used to do ad hoc queries on data in S3 using SQL. However, it is not good for real-time analytics. Therefore, this is not the right answer. Let's look at option D. Utilize Amazon Kinesis data streams for ingesting and Kinesis data analytics for real-time analytics. Store the data in Amazon S3 for analysis of ride patterns in the long term. So, Amazon Kinesis data streams offers high throughput data ingestion and Kinesis data analytics offers real-time analytics. And storing data in Amazon S3 allows for scalable and cost-effective storage, allowing further in-depth analysis of ride patterns. Therefore, option D is the correct answer. A corporation with an on-premise PostgreSQL database of 70 terabytes is planning a migration to Amazon RDS in US West 1 region. The corporation has an existing VPN connection from their on-premise network to AWS Cloud with restricted bandwidth. The company requires a cost-efficient migration solution. Which approach would expedite the migration process while minimizing downtime? So here the focus is on migrating 70 terabytes of data. A VPN connection exists and we need a quick cost-efficient migration solution for the database. So let's look at the options. Option A. Use AWS Data Sync to transfer on-premise PostgreSQL data to S3 over existing VPN connection. Then write a script to import the data from S3 into RDS. Now, existing VPN connection has restricted bandwidth. Therefore, this may not be feasible for transferring 70 terabytes of data quickly. Let's see if we have better options. Option B. Set up a direct connect link from on-premise to AWS. Use Database Migration Service or DMS to migrate data from on-premise PostgreSQL to RDS. So setting up a direct connect link for this one-time migration is an expensive proposition, not a cost-effective solution. Let's look at other options. Option C. Use a Snowcone device to transfer on-premise PostgreSQL data to S3. Import data into RDS using AWS CLI commands. This option is not correct because Snowcone devices cannot transfer 70 terabytes of data. Their capacity is much less. Option D. Using a Snowball Edge device, transfer on-premise PostgreSQL data to S3. Use DMS to migrate data from S3 to RDS. Snowball Edge device has the necessary capacity for 70 terabytes of data, and DMS can be used to migrate data from S3 to RDS. Therefore, option D is the correct answer. A corporation intends to migrate 500 on-premise servers to AWS in future. These servers operate across multiple VMware clusters within the corporation's data center. To prepare for migration, the corporation aims to collect comprehensive information about its virtual machines, including their configurations and associated details, and then explore the data. What solution would best cater to these specified requirements? So here the focus is to collect configuration and associated details of virtual machines, which are part of VMware clusters. Let's look at the options. Option A. Automate data retrieval from on-premise servers using a script. Employ AWS CLI to store server details in AWS Migration Hub. Analyze data directly within the Migration Hub console. So here we are expected to write a custom script for data retrieval. Let's see if we have better options. Option B. Export configuration details from each VM's server and upload to S3. Using ETL scripts, refine and explore the data. So here we are expected to go to each VM server and export configuration details. This seems like a lot of work. Let's see if we have better options. Option C. Set up the AWS Agentless Discovery Connector virtual appliance on the on-premise network. Enable data exploration within AWS Migration Hub for further analysis. Using Agentless Discovery Connector to gather configuration information from the VMs in an automated fashion is good, and we can explore this data within AWS Migration Hub. Therefore, this appears to be the correct answer. However, let's look at option D. Use AWS Serverless Migration Service to migrate all VM servers and then export their configurations into S3 for further exploration. This answer is obviously incorrect because our requirement is not to migrate the VM servers, but only to collect information from them for now. So option C, where we use Agentless Discovery Connector virtual appliance and AWS Migration Hub, is the correct answer. To properly maintain a popular social media platform allowing image uploads, a company aims to prevent inappropriate content sharing. They seek an efficient solution with minimal development effort to flag inappropriate images and alert the administrators. What approach should a solutions architect take to fulfill this criteria? Here the focus is on identifying inappropriate images. Let's look at option A. Write a custom script using a computer vision library to detect and flag inappropriate images. Delete the inappropriate images upon detection. So here the suggestion is that we should write a custom script. While this may work, let's look at other options. Option B, using Amazon recognition, find inappropriate content in images. Invoke this detection on image upload event. Amazon recognition employs deep learning to analyze images and videos. Therefore, it is suitable for our current scenario and is a good solution. Let's look at other options. Option C, batch process images using Amazon Comprehend and delete the ones identified as inappropriate. Amazon Comprehend is used for extraction of insights from text data like sentiment analysis, key phrase extraction, and so on. It does not work with images. Therefore, this is not the right answer. Option D, invoke Amazon Lex on image uploads to detect inappropriate images. Segregate the flagged images into a separate storage. Amazon Lex is used to create chatbots. Therefore, this is not the correct answer. Option B, where we use Amazon recognition, is the best solution for this scenario.